Alright, students, let's look at this question here, which is a pretty interesting one. We're told to prove that for all real value of x, it satisfies this inequality here. Okay, now understand that when we are doing inequalities, we're trying to, as much as we can, to factorize it because we want to see how the factors interact with each other. Okay, so this case here, I think is not hard to see that we know that x equals to 1 is a root. So essentially, x minus 1 is a factor. All right. So similarly with this guy, this is more interesting. X power 4 minus 1. Okay, I'm going to just put this as such so that I could use a square minus b square. Okay, then I'm going to just use x square minus 1 and x square plus 1. Yeah, okay, this expression here. Okay, so I'm going to start by doing that. I think the first one, you can do a long division. If you're okay, I'm going to do this. Start off with this. Then I'm going to do a long division. So it's x. Minus 1 is the root. Okay, you can do a long division, or you can just do what I'm doing now, which is juggling method. I know that I need to multiply by x squared here, then this will be plus 1, then the x here plus x. Okay, so you can do a long division, not an issue, but I'm gonna just this one could use long division. Okay, for this guy, I'm gonna just use a squared plus b squared because I'm just lazy like that, which is good. Great. Okay, then after which we could use a difference in square and square, difference of squares again. This is a square minus b square as well. Okay, so there's that. Now what's the problem here is that a lot of times students just cancel, divide both sides by x minus 1. You can't do that. Okay, this is one of the cardinal sin done by students. Because you do not know whether x minus 1 is positive or negative, you can't simply cancel off x minus 1 like that. You can't divide both sides with something that is absolutely positive. Okay, so in this case here, what we're going to do is I'm going to bring this entire thing over the other side and factorize it. Okay, so that's the whole idea there. Okay, once done, we're going to just factorize this guy out. Okay, that's a good thing. I couldn't further factorize this, and so after which we're just going to expand. I think this is not really an issue. It's quite an easy expansion here. Okay, because we can just expand this and then we're just going to sum and see what we get. All right. From here, after the expansion, just simplify whatever's in this bracket here. So 3x cubed, there's no x cubed here, so it's fine. So 3x cubed, 3x squared minus 4x squared will be minus x squared, 3x minus x, so it's minus x as well, plus 3, this is minus 1, right? That's that. So these are the expressions. So the thing is this, you could see that x equals to 1 is a root. For this is also a root, okay? So it's a root, right? So meaning to say same thing, x minus 1 is a factor. So you're just going to do a long division again. So but if you you can do long division to factorize the x minus 1 out, but I'm going to just do 3x. I'm going to just juggle it out. Okay, so this is plus 1, then that will be 3x squared. So it's minus 2x. Is it minus 2x minus 2x plus x? This is plus 2x, okay? This is plus 2x. But either way, you can just use long division to get this expression here. Yeah. Then once done, this is pretty okay because this is what we want to find. We see that this is x minus 1 square, which means that this is oftentimes this is at least 0. This is positive or 0, right? Then for the one behind here, what we need to do is just we're gonna complete the square, okay? We just show that this is always positive. So these two factors, this is a repeated root, the repeated factors, right? Factor. So if this is always positive or at least 0, then the other one is always positive. So obviously it's always any x will satisfy it. Okay. So factorize the 3 out. I'm gonna get x squared plus 2 over 3x plus 1/3. Then I'm gonna complete the square. Maybe I'll leave it here. This one. Yeah, complete the square like that. So just complete the square. Then once done, this guy multiply in will be this, and this multiply this will just be a negative 1/3. Then this will be 2/3. So obviously, you could see that this is always what do you call it? It's always positive. Okay, here plus 2/3. There you go. So just write this down. Since x minus 1 square is at least 0 and 3x plus 1/3 square, this is completed square, is always positive for all x real value. For all x real value, so all real value will satisfy the equation. Okay, so that's how you do this question here. So basically, we're able to factorize it such that this is always positive, and this is always positive as well. So any x value you give it to me, I could either make this as 0. Okay, x being x equals to 1 will be 0 lah. X, because the equality sign there is important, and x is 1, it will be 0. But any other x value given to me, it will always be positive. So basically, that's how you show that for all x value, all x real value, this will hold true. Okay, so that's how we do this question in Proficiently. If you have any questions at all, please do let us know, and I'll see you in the next question.